All right. Hello and welcome, everyone. My name is Karthik, and I'm a faculty in the University of Buffalo. On behalf of the ICRA Debates Committee in 2022, we are very excited to welcome you to the fourth edition of the debates on the future of robotics research. We have three very exciting debates prepared for you, and we can't wait to get started. But before that, I'd like to introduce you to the organizing committee. We have Sylvia Herbert from UCSD and myself as the general co-chairs. We have Sudarshan Suresh, or Sudu, who's the technical chair. We have Shreyas Kaushik from Stanford, Alex Plott from UCLA, Federico Rossi from JPL, Ken Elimelech from Rice, Benoit Rosa from CNRS, and Iris Andruso from Max Planck Institute. We've spent the last few months trying to put together an exciting program for you, and I hope you enjoy it. Before we get started, though, I just want to give you an outline of what will happen. The debates will follow a standard format. For those of you who attended previous editions, each debate will last 80 minutes. It'll feature 4 debaters, 2 for and 2 against, and there will be 1 moderator to moderate the debate. The debates will go through opening remarks, then a series of question and answers, and finally we tally the question. You can see the debate format in the slide up there. This year we are going to have the debates in a hybrid format, so there is in-person participation, but there's also virtual participation. But we will have all questions online. So if you are in person or virtual, please go to roboticsdebates.org or look at the Slido link on the right. We also, for in-person participants, we have QR codes on your table, so you can scan that for your convenience. So questions get asked on the poll there. You can also upvote questions that you like. And as the questions bubble up, the moderator will pick up the questions that are most popular. The moderator can also ask their own questions. So please be engaged, and hopefully we'll have an exciting debate. So the one last thing I'd like to say is a lot of the debates have happened because of the community and the organization. If you like the debate format and you want to participate in them, or if you don't like something and you want to get that corrected, please email us and join the community. You can participate as a debater, you can participate as an organizer. So go to the website and look up our email, send us an email, and join the workshop debates committee. With that, I'd like to get started with the first debate. The first debate is titled "Algorithms Should Not Be Published Without an Open Source Reference Implementation." I'll be joined by my colleague Federico to introduce the participants. So in the past years, the workshop has discussed several things like pervasiveness of deep learning in robotics, and we as a community have explored the reliance on data sets. Today, we want to explore the fundamental problem of gaining scientific insight into our results and making them reproducible from a different angle. And the angle is we want to talk about open sourcing the work we do. Right, so that's the debate topic. Federico?
Yeah, arguing. So before we begin our debate, we want to take a temperature of the room. So please go to the Slido at this URL or scan the QR code and vote on whether you agree. We will also have the vote and the vote at the end of the debate. We have 4 stellar debaters and a wonderful moderator today. Arguing for the proposition, we have Professor Amanda Prorok, who's an associate professor in the Department of Computer Science and Technology at Cambridge University in the UK. Amanda's mission is to find new ways of coordinating artificial intelligent agents, robots, vehicles, and machines to achieve common goals in shared physical and virtual spaces. And we also have Professor Van Halperin from Tel-Aviv University, Dan's main field of research is computational geometry and its applications. A major focus of his work has been in research and development of robust geometric software, mainly as part of CGAL, the CGAL project and library. Application areas of very interest include robotics, automated manufacturing, algorithmic motion planning, and 3D printing. And Amanda and Dan will be debating for this topic.
And arguing against the resolution, we have Dr. Vandi Verma from NASA Jet Propulsion Labs. Vandi is the Deputy Section Manager for Mobility and Robotics Section at NASA JPL. Her areas of expertise include space robotics, autonomous robots, and robotic operations. Joining her is Dr. Andreas Bihlmaier, the Chief Software Architect at ABB Robotics. Dr. Bihlmaier obtained his PhD from Karlsruhe Institute of Technology, Intelligent Process Automation and Robotics Lab. After that, he worked at Google Research in 2015, and Andreas returned to Germany to co-found a robotics startup, Robotics GmbH, which designs individual automation solutions based on an intelligent modular system. So we should have an exciting set of debates. Again, like Federico said, there is a pre-debate poll. Please scan the cards. Please go to the Slido and enter the pre-debate poll so we can get an idea of what the audience believes before we start the debate. Okay, as the pre-debate polls are going on, I will hand it over to our moderator, Dr. Taylor.
Hey, good morning, everybody. Looking forward to a robust interchange of ideas, as these things always prove to be quite interesting. So with that in mind, I think I'm going to just give you a temperature of where we stand currently with this proposition. Perhaps unsurprisingly, for an academic conference like this, currently around 61% agree. Surprisingly, perhaps not, 21 undecided is second at 21%, and the remaining 18% disagree. So we'll see whether there's any motion on that as we go forward. So with that, I'm not sure if there's a prescribed order for speakers. Okay. So I will exercise a royal prerogative here and invite the floor side to send one speaker forward. I know Amanda or Dan, which of you would like to begin? Not. I think I'm just going to invite Amanda to start, and then we'll go against, and then for, and then against him. So.
Okay. Thank you, CJ, for the introduction and for acting as moderator. Good morning, everybody. So I'm going to start by talking about three key points that I believe are crucial to the position for this argument. The first one is that I believe that open source code is simply good practice. So it essentially forces you to look through your code and make sure it doesn't contain any mistakes. And ultimately, I think that having this goal in mind, so open sourcing your code, really does enhance the quality of your own research, which can only be a good thing. Simultaneously, it also allows others to verify that you haven't had any mistakes. So there is code improvement, code quality improvement coming through this process in many different ways. The second key point is reproducibility. And this point is extremely valid for the academic community. So most papers often do not contain all necessary details and information needed in order to be able to reproduce results. This can also be because many publication venues have stringent page limitations, and even if you add an appendix, key implementation details are hard to include in paper form, where you don't actually include the actual code itself. So reproducibility is sometimes only possible if you actually provide the code. Then the second point that's arguing for reproducibility is that, and that connects to the third point, is comparisons and evaluation. So benchmarking. It's easier to benchmark and it's easier to be more truthful with respect to comparisons when you actually get the source code of the original developers. It's easier to do benchmarking when you actually get the code from the developers themselves, especially if you're trying to outperform a prior method. You want to make sure you get the best possible code, and that would often be through the developers themselves. And the final point I want to make, and it relates to all these three points that I made before, is the impact that these three items bring about. The first main impact point is that it accelerates development, accelerates research, and through this acceleration, we are able to perhaps more easily level with the private sector, with industry, because we're leveraging a community effect by open sourcing our code. So a concrete example is, if I can take the open source code of a prior paper and build on that, perhaps to extend it, to provide a slight alternative, or maybe even to improve it, having that open source code available to me cut several months of development time out of my busy work schedule. So this is the kind of acceleration that I think is very valuable to academia. At the same time, we're leveraging a community effect. So we're leveraging the effects of academia. And I think that this is what is at heart for many practitioners in the research realm. We want to be able to leverage this community effect. We want to be able to work together as a team, and we want to further research as a whole. Last point I want to make is actually the point that it's a two-directional, the benefits are two-directional. So if you think about companies, many companies actually also decide to go down the open source code route. And the reason for this is that it benefits you back. So if you think concretely about the examples of PyTorch and TensorFlow, these are two frameworks that have been open sourced by Meta, Facebook, and Google, respectively. And by open sourcing those frameworks, they're opening up the tool bases that they use internally to a user base. Any products that are then developed by this user base are more easily integrated back into products that these industries can then further develop internally and potentially again outsource and open source. So the open source cycle just keeps on continuing in a very positive, uplifting way. I think I will leave it at that and hand over to Dan for additional points.
Thank you very much. Thank you very much, Amanda. And your timing is impeccable, as always. So with that, I'm going to ask Andreas to advance the initial argument against, and then we'll go to the end.
Yeah, happy to. So hello and good morning, everyone. So I take the stance against in this debate. So let's start with questioning, why would we request to open source the reference implementation if the algorithm has already been published? So what is the goal of having an open source reference implementation? And is that goal actually furthered by doing open source reference implementations? I think that's one point we should get an answer for by the proponents of open sourcing the implementation. Another big topic is that I expect less contributions by industry if industry, private sector is forced to open source their algorithms. So instead then of getting at least a paper that describes their methods, we will get nothing for the wider research community. The next point is that I believe it does not actually address the reproducibility challenge we have in robotics, because software is often not enough. I would also at least need the data, but more importantly, I would need the hardware, and not just the robot hardware. I would also need the environment, perhaps the whole lab, including motion capturing systems and other things to actually compare the reference implementation that was open sourced. And another topic regarding reproducibility is, of course, is the task that is presented in the paper actually representative, or is it relevant for what we want to find out about the algorithm? So it might be, the algorithm might work quite well, and I can verify that, but I might easily find out that the task is posed in a way that it is actually not really that relevant for what we want to achieve in the wider robotics research community. Finally, the next point is, if there is an open source reference implementation put on GitHub, it might lead people to not spend so much time properly explaining their method. They will just refer to, look at my code, read what I open sourced here. So not having an open source implementation will actually force people to make a better write-up and condense the hundreds or thousands of lines of code into something that fits in an IEEE paper format. So there is a risk of actually reducing the paper quality if people just can refer to their code all of the time. And another important question for me is, the idea of open source is that there are many eyeballs on the implementation, and that will find issues, that will detect people, perhaps making things appear better than they actually are because they're selecting good inputs or good applications for their method. But the principle of many eyeballs only works if there are actually many eyeballs. If you look at GitHub and how much code is published there, you can just make an argument that there cannot be too many readers on average of what is being published there, given the amount that is uploaded. And let me conclude the first statement with that it is bad for innovation, forcing people to open source a reference implementation. And with innovation, I do not mean the scientific part of it, but more the commercialization and bringing it into the real world part of it. Because if I come up with an interesting solution during my PhD studies, and I can use my implementation as the basis for starting a company around my new method, I have a higher chance of succeeding and getting funding than if I had already open sourced everything and the big companies can just come and take it. And since I still have, I think, a few seconds, then one more point is it is a significant time investment. And wouldn't I rather have my PhD students do robotics research than working on maintaining open source software? I think that should be some points for that side of the argument.
Okay, wonderful. Thank you, Andreas. And again, everybody's doing sort of a wonderful job sort of keeping it within 5 minutes. So that, I guess, leaves a little bit more time, I think, for our next two speakers. So with that, I'm going to turn it over to Dan for the next 5-minute segment.
I want to thank the organizers for inviting me to participate in this important debate on a topic that concerns many of us. Amanda already put up the main points, and I'll try to strengthen her points and to contradict some of Andreas's points. I strongly support publishing code with algorithmic papers in robotics. Don't try to produce product strength software. Don't spend too much time on beautifying your code. Just share with us the code that we can read and run so we get a better feeling for how the algorithms are implemented and how they perform on instances you may not have studied. There are many reasons to publish the code along with the algorithms. As I said, Amanda already mentioned most of them: transparency, reproducibility, comparison with other approaches, expediting the progress of algorithmic research in robotics, but not making anybody start the effort from scratch. The code is a natural extension of the high-level description of the algorithm. When we describe an algorithm in a paper, we omit many implementation details. Most readers of the paper would probably prefer not to be distracted by these details. But some are interested in them since the research is close to theirs and details matter. Let me repeat an often used but still wonderful quote attributed to many people. In theory, there's no difference between theory and practice. In practice, there is. I cannot think of an area where this is more suitable than algorithms in general and robot algorithms in particular. I love theory, but in robotics, we have to relate the theory to the practice. Adding code to submissions had an unprecedented effect on the fast-paced progress in machine learning. Code submission is not compulsory, but quite often reviewers frown upon papers not accompanied by code. Papers which may otherwise be good. It may not be the official reason why a paper is rejected, but a paper may lose a lot of points due to lack of code. Moreover, it's quite evident that good papers accompanied by usable code have higher impact. Results obtained in academia should be at the public domain. They should be open source, software code included. You may argue that the need to reveal the code will lead to too much preparation time and effort. Then, instead of having K-1,000 submissions to ICRA and IROS every year, we will only have K-1,000 submissions. Is it really bad? Won't we then have more thorough, better checked, reusable submissions if people knew that someone will be looking at their code? Don't worry, no one is asking you to become an Uber programmer producing gleaming code. We just want to learn how you handle the fine details. If your code is reasonable, we could also build on it for further development. Algorithms should not be published without an open source implementation. That's the end of my first set of arguments.
Fantastic. Looking forward to hopefully spirited debate as we go forward on this. So with that, it's my pleasure to turn to our final speaker, Vandi, and I'm actually really curious to hear when we can expect the next GitHub update from Mars.
Right. No, I think it's always interesting to go fast because a lot of the discussions have been made. But I think that robotics publications should be inclusive to all types and stages of research. So, I think of publications at all forms of documentation, and they serve the purpose of providing detail for those who present an article, but also for those who may not have entered the field now to catch up on what was being done and discussed because they wasn't there. So, I'm a huge fan of our article process, replication, and benchmarking, and also the GEM processes to have experiments. I think that's really great because it makes it explicit what that label means, what was verified and what was not verified. At the same time, I think we should allow sharing of works that doesn't need to fit into that criteria, because otherwise you would hear about it. So I think for primary robotics researchers and academics, the purpose of the publication they may be doing is for the purpose of that publication, or for robotics competition or demonstration. But if your primary, and that's your job description, you need as part of your work, for those who work on real-world robots, you may be doing this innovation as part of the custom infrastructure. And oftentimes, you can be successful at your job without ever publishing. And in fact, you may have to be publishing in your spare time and have to jump through a lot of hoops to get that information out there. So I think, we don't want to miss out on having those people be part of the discussion. Another aspect is it could delay discussion of early work. There could be somebody who's really good at formulating data, especially when you don't get so detailed that you know the ins and outs of the algorithm. If somebody lays out an argument against a specific point, it would still be really valuable for the discussion. So all of the work that's being submitted should still go through peer review, but it's the peer review that should decide whether it's valuable for the community to have this. And And then I think my main disagreement with the opposition is the statement as it's phrased, which is that publications that don't include an open source implementation would be rejected before anyone even reviewed them. We should at least give them a chance to make a case that they provide the value. And alongside those that do provide the open source implementation. So I think my opinion thing would be that the transparency is great. It's great to have the transparency as to what is being peer-reviewed, what's the process, what's the criteria, and in fact, we should do that for whether or not. I think there's one process that will be reproducible, and you have checklists and what is being checked. But they should, and particularly like the part where they can do a result article published of how they test the result, and the authors can oppose that. We should do that even for the ones who don't include the publication. I think that's the main point, is being able to make it visible what the criteria is, uniform and equally applied.
All right, fantastic. Well, I really want to thank all of our speakers. It's a really clear, I think, coherent arguments currently being made. I actually just wanted to remind the audience that all of our questions are being captured via the Slido interface. I don't know, Karthik, if you want to give us a reminder on what the URL is?
Yeah, for the in-person people, every table has a QR code that you're welcome to scan, and that gives you that. And online, if you go to roboticsdebates.org, the link is also there, and the questions are right there. So you can post questions, you can upvote things. I don't know if you can download things, but you can definitely upvote the questions you like.
Okay, and with that, so I'm going to we're going to proceed into this moderated discussion piece. So I'm going to be picking some questions from the Slido interface again. Please log on, and some of my own. I'm going to use to stir the pot. So with that, let me just read out a question that's been posted. If open source code becomes a mandatory part of publication, should it then also be taken into account during peer review? And if so, how? And I guess this really goes towards the four arguments here.
I would say not necessarily. It all should be done with great care because it can really increase the burden on the reviewers. It should be an option for someone who is interested and is looking into the code. It should not be compulsory. If a reviewer wants to check it, they can. If they don't have to.
Any comments from the against on this question of incorporation into peer review, and what, if anything, should be the burden on authors in terms of the code that they produce, if, as stated in the proposition, this is to become a mandatory part of submission?
I think if we make submitting your code mandatory as part of handing in your publication, but not reviewing what is actually contained behind the link to the repository, then of course the question is how much value is there? Is it actually the right code? Does it compile? What quality is it? So we need to be consistent. If we demand publication of the code, then we also need to review it as part of reviewing the submissions.
Okay, so I'm going to invoke executive privilege here and actually ask a question for the group against. So Amanda made a really excellent point about the salubrious effect that sort of open source has had sort of on a wide range of things in terms of being able to produce artifacts that other people can build upon in various ways. What's your response to the idea that this is actually sort of a good thing? It leads to a virtuous cycle of innovation. Do you think she's wrong about this, or that there are other ways of achieving it?
Yeah, at least I would say I think it's really great to have the open source implementations, because it is true that we can use those implementations, but it shouldn't be the requirement. Is I think the phrasing as it's stated is the articles without it are published. There is definitely value in my mind in having open source, and it results in people being able to use it, but not everything is conducive to it. You have to build enormous infrastructure sometimes with more complex algorithms. And if you simplify it and not actually testing with some of the benchmarking, that is also being discussed. I don't know if Andreas has anything to add to that.
We didn't quite catch the end of your sentence. If you could just repeat that. Yeah, the audio is.
I'll try to hold the mic.
Oh yeah, that's great. Thank you very much.
That's better. Sorry about that. I think I was just saying that my point was that open source is great to have. It does provide value, but rejecting articles that don't provide open source implementation is more the argument against it. And also some of the types of work that is done on real world robotic systems can be part of very complex infrastructure. And without it, you won't get the same benchmarking results. So if you simplify it, you're actually discussing an entirely different problem.
So I don't know if Vandi, you want to sort of respond or talk about the.
I can say a few things. I think the question of accepting or rejecting based on whether or not code is available is actually an entirely separate discussion. Because, yeah, I think the question we are discussing, I believe, in the first instance, is whether some code is available or not, right? So the availability of open source code. The quality of that code obviously will vary a lot. And we're talking often here, we're talking about, PhD students, potentially postdocs who are open sourcing perhaps even their first big project. But that, I think, is even part of the pro argument here. Open sourcing code and creating a community around a bit of code is even educational for those who open source the code. So they will learn through the interactions of the community. Often PIs have, perhaps a dozen students under them or multiple dozens in the worst or the best of cases, right? And we do not have the time to scrutinize code and help our students improve it. So I think the open sourcing here is not a accept reject question. Rather, it's I'm providing you this. Please get back to me on it, right? And I think as many communities in the machine learning domain already do, it's a checklist requirement, not something that has been reviewed. And if you're lucky, you go onto the GitHub, you install the stuff, and you run it. And it's a question of a couple of minutes. And it's not a question of actually reading the code and judging its quality. It's a question of, okay, can I run the model or can I run the system? And the results it's giving me, can I use those to benchmark a potential improvement? And just that action of having that code available and being able to do this cut a couple of months out of the next person's development time. And I think it's this acceleration of science that we're really, really trying to strive for here.
So there's another question from the forum that I think I'd like to address against right to the far side of the aisle. I keep seeing students use code without understanding it. Boy, I've never seen that happen before. What are your thoughts on implementing algorithms yourself as an important aspect of learning the research sector?
So I would definitely say this is a great example of if you have the code available and you can just run it, you will not perhaps study what is presented with the same level of detail and attention than if you would look at really the essence of what is being published, the method, the contribution to robotics. You might just run it, and a lot of innovation likely will come from people looking at the more abstract description, trying to implement it, and then running into all kinds of corner cases, running into all kinds of problems. And they might actually indicate where this method could be further improved or what alternatives might be taken. If you just download code and run it, you might never have that moment where you really need to deeply think about the method that you're using here.
I'd just like to add to that sometimes, and there are examples when you work on the robotic systems, that an error in the code can produce positive results to reinforce your end result. So you really do have to look at the code to make sure it's actually implementing the algorithm as intended.
I want to react to some of the comments by Andreas. May I?
Please, of course.
First, the earlier claim that what's the point of submitting code if the reviewers don't review it? I want to give an analog from the best algorithms and theory conferences in computer science, where you are now required to supply all the proofs to your theorems in addition to the main body of the paper. No one promises you to read this, like no one promises you to read supplementary material in robotics. But it gives the opportunity to those who are interested to check it. Or if there is some debate over your paper, there is extra material where you can be checked upon. So it's probably unrealistic to expect that on top of all the review process that we are swamped in, we will have to check code. But having it there can increase the quality of the research and the ease of reproducibility.
Let me just have a quick follow-up question to this one. I guess this is going to be addressed to the guest. Do any examples spring to mind of situations where actually having a open source or their implementation available is actually detrimental? Are there situations that you've seen where a particular package or a particular implementation gains traction or causes people to think less hard than they should? It's possibly an unfair question, but I think it's a stir pot.
Sorry, I didn't get that comment.
I was just wondering if theoretically, let's say, it would be possible to have a situation where actually having a reference implementation out there might cause people to look a little less closely than they should, and sort of rely on what's done. Are there any sort of famous software bugs that you might have come across in practice, or that you felt might have been ameliorated if it had been re-implemented or looked at a little bit more closely?
Maybe Andreas has an example, but in general, I would say that the argument isn't that open source is good. It is valuable, but I think just now I'm hypothesizing, but if there is an implementation and there exist certain examples of like provided infrastructure, that a lot of work just goes upon that, and sometimes we start thinking of innovative ways outside of that box. And so, that could be an example of it. I actually think open source is quite good, but in general, that could be an example. So we should also have diversity in the open source implementations. So we are exploring research ideas.
Another question that's sort of risen to the top here online is really about this question of the implicit burden of producing software architecture. So isn't it placing an additional burden on academics to open source their code and make it reusable without added incentives after the paper is published? So I guess this is the question for the four candidates.
Yeah, perhaps. Oh, Dan, do you want to go?
No, go ahead, Amanda.
I mean, I have, it's a short answer to that. And I think, so the answer is yes, it is a time commitment, and time is valuable for, PhD students, because we know that they're under a certain amount of pressure to get a lot of work done in a short period of time. But I would argue that in any case, always, this time investment is worth it, because if you're intending to build on something that you're producing, you want to make sure that what you're producing is good. You're going to want to make your codes, your source code legible. After you come back from a holiday, you want to make sure that there's a README file so you know how to get started again. I think there's only only benefits to producing good code for the person who developed it, as well as obviously anybody else who might want to use it.
May I add to Amanda's comments? On my floor in the department, there are many machine learning people, and I polled them before our debate, and they said that if you have good code accompanying your papers, it clearly increases the impact of your paper. The chances that you will be cited are manifold higher than without good code. So you get benefits, even credit benefits in publications.
All right, there's another question in the chat, which I think builds upon a comment that Andreas made. So as Andreas mentioned, code most often needs data to run. Is there any value to code on its own? And again, to remind you back to some point is that in many situations, these are also associated with bespoke hardware or other configurations that might be unique to a particular experimenter or setup. Should contributions that rely on these kinds of things also be outside of the realm of public publication? So just throwing it to both sides here. Andreas, if you want to amplify, or Dan or Amanda, if you want to respond.
So I can perhaps only amplify it in terms of, we also need to ask ourselves if the method described in the paper is not novel enough that this in itself is a valuable contribution to robotics, but that only having a complex implementation that gets some problem done, whether we are then still talking about research or whether we are actually talking about open source products that we would like to use to build research on. So, if you need the code to get value out of what was published, then perhaps there was no value in publishing it in terms of it being a scientific contribution.
I would like to say something here. So I think the key point in my answer is modularity. So, and the second key point is the paper or whatever contribution you're trying to make, is it a data set or is it an algorithm? Clearly, if it's a data set paper, then open source here consists of data, right? So I think it's a question of what is the context that we're talking about here. If it's an algorithms paper or methods paper, then the code should be modular such that you can load any data that is relevant and run your algorithm on it. And the data itself, so the algorithm itself should not be data set dependent. Instead, in your README files or any ancillary documentation, you should clearly describe for what kind of data sets your algorithm works. But the data itself does not have to be part of the contribution.
There's another question in the comment that I think is sort of worth amplifying on, which is if the goal is sort of replication, is it really needed to publish the code? Is there a room for a halfway measure where you provide, let's say, a closed source implementation or simply a binary variant of the library, which has certainly been done in various, which might allow people to reproduce results without necessarily revealing trade secrets, let's say, if that's something that you wanted to protect. So curious how both sides of it sort of feel about that. That's a possibility.
On occasions where for some reason it's impossible to reveal the code, that's a compromise. That would be good enough if at least we can test your code on other data, understand the performance of your algorithms. But of course, it would be better if we could also see how this was created.
Andreas or Vandi, any thoughts? And would this assuage some of your concerns, or?
So of course, it definitely addresses the IP, intellectual property related questions. However, in practice, it might even be harder to perform this because what binaries do you ship for what operating system, for what languages, for how many years are they going to run? Because most people are not only interested in the papers of a year or two ago. There has been very valuable things that are still valid 10, 15, 20 years after they have been published. And so it might be very difficult in practice to do binary publications.
Right, well, according to the clock, we're at 10:46. So I guess let's, according to schedule, we are now moving to a phase where each debater will be allowed 2.5 minutes to make our closing argument. After that, there will be a final poll to see if we've swayed any minds one way or the other. So I think I'm inclined to basically go in the same order we did for the beginning. So Amanda, you'd be up first.
Amanda, we don't hear you.
Yeah, got it, thanks. To keep it really short and crisp. So I think open source code is beneficial for the acceleration of science, and it's also beneficial to the development of anybody who's producing that open source code because it enhances the quality of the research. Overall, I think it's definitely the way we should go, and I'm happy to see many research communities adopting this strategy. I think the robotics community should should really adopt it as well, and actually follow even some companies in the private domain who are already doing this.
Okay. Andreas, you'll be up next.
Yeah, I'll also make it brief. So I think we will not achieve what we set out to achieve by having this requirement of publishing an open source reference implementation, and we will actually negatively impact robotics research because a lot of private contributions will not happen anymore, since either their code is part of a really big proprietary in-house system and they cannot just modularize that and give snippets out of it that you actually can run, or they have a lot of concerns about intellectual property and would just refrain from publishing it all and continuing it with their research internally.
Okay, Dan.
I try to make it short as well. I suggest that you Google publishing papers with code, and you'll see that there is some revolution going on in the world, and communities are adopting this attitude, this approach. Don't take it to the extreme, but let us look at your code. If you have very good reason not to do it, we will be tolerant. But let's proceed with open source research and open source code.
And last but no means least, you get the last word.
I just want to make sure that those online can hear me. Sorry, initially I think there were some problems. Can you hear me? Oh, okay, great. So I think it's great to have open source code, and we should definitely encourage it. In fact, we should include people who aren't classic academics, for whom it is harder to find out how we can provide, in a way, as an organization, guidelines that might help one from the other to do the open source work. And I also think the statement as it's written, I still disagree with, we should continue to be inclusive of all types and stages of research. So we should require it, but we should find ways to enable and encourage it.
Okay. So with that, I will mention to the audience, both here and online, that there is a poll now up on Slido. And I'm going to give you guys a couple of minutes to log on and give us your feedback. So while we're doing that, I figured I'd ask one question, which is hopefully relatively anodyne, which is actually a bit more about possible implementations. I'm hearing a lot of general agreement that open source is a good thing, but there's also sort of a concern about the costs associated with the ability to maintain such a thing afterwards. I'm wondering if people have thoughts on the advisability of setting up institutions, maybe making this a part of this mission. I know that National Institute of Standards here in the United States, or other bodies that could serve as repositories for data, for implementations, to make them available. So I'm wondering if you guys have thought about that, whether you think some sort of thrust in that area is a good thing, or we leave it as a tragedy of the commons kind of event.
It's a tough call. It's very hard. From my experience over the past decades, it's very hard to maintain open source code in a satisfactory way. Probably you would like to have some involvement of industry in one form or another. But the issue of maintenance, I think, is slightly different from the main topic of our debate. The hardness of maintaining should not convince us not to ask for open source submission. This is a somewhat different question. And I have a lot more to say about it, but I think it needs another debate.
Yeah, I think that it is very valuable to have the discussion of how it could be enabled, because generally sometimes the open source is put it out there and it's left to the consumer of that open source to figure out how to do it. So it would be valuable to see if they can do it. It's not going to be easy.
All right, so with that, I think we can reveal the current temperature of the room. Unfortunately, it's flipped off of my display, so I think you want to.
Yeah, Federico's doing it behind the scenes.
And by one.
So once it's ready, he'll share it right up on screen.
Okay. So with that, I think why don't we just start to proceed into the debrief session, which is also sort of useful. We can go two ways. We can either engage in more pungent remarks, or we can talk about how we actually feel. So again, I think, as I said, there was a lot of love for open source, I think, across the board. The interesting question sort of still revolves around these questions of cost, questions of maintenance, and intellectual property. I'm just wondering for on either side if there are any arguments that the other side made that you sort of particularly wanted to respond to that we didn't get a chance to get to during our time so far. So again, it's open to anyone who wants to.
So now that the polls are over and we can choose perhaps also different sides in the in the debate. So of course it was an interesting experience to take the opposite opinion of my actual one, and trying to find good arguments against open sourcing your implementations. But I think still it was a valuable exercise, not just intellectually, but also what do we want to achieve? So I think that question really stuck with me, and perhaps it's not open source. So I think two topics emerged over and over. One is reproducibility, and the other is being able to build on what others have done in order to successfully, or one step at a time, build up complex systems, because no single PhD candidate can write everything from scratch and still hand in a thesis in time. So we kind of need to build on what others have done, and in a domain that is as applied as robotics often is, of course the question is what is this fundamental basis? It is not just the the new methods that have been developed, it's not just theoretical insights, it is really, you want to get started from a higher level. So you want to stand on the shoulder of giants, of people that have worked before you, so that you can start from where they left off, instead of starting from where they started and then not getting much further than they did in a limited amount of time. So I think those are the two fundamental topics: reproducibility and incremental progress in robotics research. And I think open source is part of the answer, but it's not the full answer, actually. And that is what really shines through the discussion for me. There needs to be more than open sourcing your PhD code.
I would also like to raise a point that I wouldn't have raised when I was supposed to defend open source. I've been involved in open source in academia for many years in a huge project called Seagull. It really made a transformation in computational geometry, but I want to warn you of one thing. Don't turn your PhD students into software engineers. Eventually, it doesn't pay off in academia. It's a very thin line here that should not be crossed. We need open source projects. We need enthusiasm of students. Many students like to contribute to code, but if they contribute to code instead of doing original research, they will be later taken to excellent, lucrative jobs in the best software companies. But for remaining in academia, you should be cautious about these aspects of the time, the time that your students spend. At any rate, this doesn't again preclude the need to publish open source software due papers, but it's better to keep it at bay.
And I think in terms of that, one thing I was briefly going to outline with Rick very cool, is that, a lot of companies and even like Mars work and other things use open source work in the initial stages. So I think it is important to get back to that so that it could then be used by other places. So I think the open source discussion is definitely valuable in that regard to facilitate, because they are using some of that as well.
So with that, I think we can share the final results. Okay, so there was a little bit of interesting shift in opinion. After debate, the agrees have gone to 36%, the disagrees to 54%. I guess it'd be interesting to actually get if there are people that are interested in posting online about the arguments that you felt sort of most swayed you. I think that might be something that people would be interested to hear about. There was actually sort of one point that I think Andreas made that I was hoping to get a little bit more reaction to, is in some sense the difference between writing a paper and writing code. And that again, the usual standard had been that someone suitably skilled in the arts, after reading your 8-page paper, would be able to have a fair shot at being able to implement it again. And the ability to sort of essentially put all of your source online, in some sense, could be viewed as an invitation to be a little less crisp in your descriptions. And I think this is related to another point, which is that while your ICRA submissions are all archival, they get stored. There's a process by which these things become part of the historical record. We don't quite have that same level of archival rigor when it comes to code. It's a bit more ephemeral. And if you end up with a situation where stuff is is put in code but not necessarily actually described, that could actually be a potential problem in terms of sort of long-term ideas that we get out of the literature. So I just wanted to throw it, I guess, to the floor, but I guess the against. I just wanted, I don't know if I captured Andreas's argument.
Perhaps to add on to this point, one question I often ask myself while I was in academia is really this: what is a contribution to robotics, to computer science, to whatever the area of study is you're working in, and in robotics it's often really hard to tell. There are the fundamental algorithms and fundamental breakthroughs that happen from time to time, but of course not the 1,001 each ICRA either. And a lot of the contributions actually are very much in the details. But if your method depends on minute details that are contained in the implementation in terms of handling edge cases, in terms of normalizing some data, whatever it is, then perhaps shouldn't you describe that in the paper if that is the actual contribution? Because if it's just a paper of I was able to get this to work, perhaps then you shouldn't write the paper, then you should just publish the source code and the video. So it's a bit a question where we need to reflect on what is the contribution in each and every publication. And sometimes perhaps the higher value is the implementation and not the paper, but then we should also handle it like that and be transparent about it, instead of pretending it's the paper, but actually people cite it because they like to use the implementation. But the paper doesn't contain anything new.
So yeah, Dan, I'm wondering whether this sort of echoed a couple of the points that you were actually making earlier about not turning our students into software engineers.
Don't publish a paper if you don't have good new ideas. The source code is an addition. There are venues in academia, special journals that publish code. You'll find also ample information about it on the net. If your main contribution is code, there are different menus than the major robotics venues to publish it. The assumption when you publish a paper is that you have some good new ideas to share with the world. The software is support for that. If your contribution is the software, that's a different thing. There are venues to publish it, but you should take into account that the contribution is of a different nature. And I don't think that these are the contributions and the papers that we were mostly referring to and talking about in this debate. Here we talk about original new research in robotics. I think it's very rare. I mean, I think there is room in ICRA and other conferences to publish major open source projects, but these are very rare. You want to publish them and then you are using these and then you're giving credit to the people who did them. But on a regular basis, if your main contribution is software, that's a different story. I don't think, we are talking about a situation where the main contribution is algorithms. If you are original in the algorithms, very nice. It would also be very nice to see how you made it into a program. But I probably should be careful after this avalanche failure in the polls. So I should let others speak.
Just to add to Dan's point, I think the proposition here, the devil is in the detail, right? Because what we're arguing here is that it's not optional to provide open source code. Our proposition here is that it is obligatory. And I think there's a very fine, well, actually there's a stark difference between the two, which, yeah, obviously is critical here because, you know, to be honest, if I now had to argue with my personal opinion, I think that an obligation is probably a little bit tricky for many reasons, IP being one of them, and the second one being timing simply. Often we're trying to get papers done in time for the deadline, and we're not ready. We're not ready with the code because we want to do exactly that, which I mentioned in my arguments. We want to make sure the code is proper, it's readable, and I can use it again myself or the community. And that might take an additional 1 or 2 weeks of work or maybe more. And so getting the timing right for that is really tricky. So, you know, I guess having a checklist at the end, as some machine learning conferences do, is probably good. It means it's not like, it's not make or break if you have the code, but it's a plus. And I definitely am for encouraging it, but I'm perhaps not for making it obligatory.
Well, actually, maybe this is a separate debate, but I was intrigued by the idea, you know, because it happens a lot in my field of work that you could be doing something on Mars for 10 years, running the code every day, and then you discover a problem. You've been done. And should that be original research to address your algorithm so it makes it so that there's new algorithm, but that doesn't occur. I still think there's room for that. And I was curious what all of you think more about that, Nick, because, you know, it would be great. That isn't just a software problem, I think. Maybe the next debate.
Maybe there's actually information to be gleaned by actually looking at the GitHub updates to see what was fixed and when.
Yeah.
So with that, I guess I'm going to ask if any of our debaters have any final thoughts they'd like to share with the audience. If not, there's an incipient coffee break, which I'm sorry we can't share with our online participants, but I hope you will definitely avail yourself of that opportunity and extra couple of minutes today.
And I was hoping some coffee break delivery drone has started in Philly a couple hours ago and will now fly in here to my window, but perhaps ICRA 2030.
Yeah, so we'll build upon the hyperloop that we're going to be building here. Okay, with that, I just want to express my deep appreciation to all of the debaters. I know how much work it is to sort of get your arguments ready for this, and to the organizers who spent so many hours getting all this done, and to the audience for the many wonderful questions. Just apologize if we didn't get a chance to get to all of them in time available. So with that, I'll turn it back to Carthen.
Actually, Federico Online is going to wrap up. Federico?
Yeah, thank you all. Thank you all in the audience for joining us in the room and online. Thank you so much to Amanda, Dan, Vandi, and Andreas for an exceptionally engaging and thought-provoking debate. We're commenting, I don't think we've seen such a large swing in any of the previous debates. So this was amazing. Thank you so much to CJ for being a spectacular moderator. We'll have a 20-minute break, actually 30-minute break, I believe. We'll be back at 11:40 Eastern. And yeah, see you in half an hour. The next debate on research in robotics is intrinsically a social good because we seek to solve the dull, dirty, and dangerous stuff. And one last comment, if you're enjoying this, we strongly encourage you to join the committee that organizes this. Send an email to roboticsdebates@gmail.com. Thank you all so much. See you at 11:40.